Alright, today I'm going to do a little revamp on my previous high pressure boiler uh, model that I built and go into a better explanation and show you how this works and show you how you can build one yourself. And while I'm going to fire this up and I'm inside, it's cold outside, so today I'm just going to be using rubbing alcohol. And as you can see, I'm starting the gauge at 0, pressure relief closed. I've already previously filled the boiler with water. We'll get this going and fire it up while I'm talking so we can see it at work. Alright, gauge at 0, we're going. So all my projects on my channels are built from recycled parts. You can very easily build this with very little imagination. My base is just a metal base. I've leveled it with bolts. I made a pretty firm stand for my project. My burner is my camping burner stove that you can see on a previous video. Very easy to build. For this project, it's perfect. And you can already see on my gauge I'm building pressure pretty good. So let's go into the boiler and boiler principle. So all the boiler is a sealed boiling chamber. Because it's not so much important the boiling water as it is the steam. And you're creating high pressure steam. In the old days, they'd use the high pressure steam to push against the turbine to turn the turbine on a locomotive or a ship for power. And that's what I'm demonstrating here. So I got a double-walled hollow chamber I filled with water. I got my pressure relief valve right here, which is just a gate you open and close. You could use a ball valve or anything. I got my pressure gauge, just a standard pressure gauge. I've piped it all in so it's sealed so I can build pressure. I got my stack, so I'm sending heat through my bottom burner through the boiler and coming out the stack, so you have a pass over of heat, one pass in this particular circumstance, and I'm really building pressure really good here very shortly. But I built this myself and I know how much it can take. We're fine. I spent 6 months in boiler school on a previous occupation, and I was a certified boiler operator as well. In a minute I'm going to release pressure so I can show you what we have. So a lot of people get this wrong. It's not condensation, it's condensate, and that's the way a boiler works. It's like saying perspirate and perspiration. Well, what is perspiration? Perspiration is the accumulation of perspirate because you're actually perspirate. And that's the same with condensate. And I'm really getting high on the gauge. There's a lot of pressure in here. And that's basically how it works. It can be very dangerous. On a real boiler, you'll have an emergency release pressure valve, and it's set to a given pressure. Like if you get up into a red zone on gauge, it's going to automatically trip, pop open, and release the gauge so the boiler doesn't explode. In the old days, they got into a lot of problems. There was a lot of ships where the boiler room exploded, a lot of locomotives, the boiler exploded. Those guys were basically flying blind. They didn't have adequate gauges. If and when they had adequate gauges at all, and to get more power, they had to stoke the boiler more. And you can see now that my fire, this is a perfect example, my fire's gone out, so the boiler pressure stagnated. Now, in the old days when they needed more power, they keep stoking, and put more pressure on the boiler, until finally they got into a red line issue where the boiler was going to fail. Now that my fire's gone out, I'm going to hit my pressure relief gauge and release the steam, and you can see what we built in there. And there's your high pressure steam. And at the same time, you can watch the gauge drop as it's releasing. This model worked perfectly. That's exactly what you want to see. Now, if you want to build one yourself, you're going to have to use something pretty substantial. There's many videos on YouTube and other places on the internet where you can learn how to build a boiler for many different applications. The important thing is you have a boiler chamber that's strong enough and sealed good enough to take whatever pressure you're going to send at it. Do at your own risk. If you don't, you're going to blow it up. And it's still going. It's still releasing pressure all the way back down to 0. And just from that short little time, that's how much pressure that built. It's pretty amazing. Now you could make a emergency pressure relief valve. You could buy one for a hot water heater. You could modify one. There's many different ways to do it. I have a manual one because I'm manually running this boiler. I'm watching the gauge. And if it would have got to an overpressure issue, I would have manually released the steam like I just did. And she's still going. Just from that short little demonstration and that short little demonstration time, that's how much pressure it had and built. many different applications you could use this for. It's incredible the amount of different applications you could use a home boiler for. And it's a lot more than just heating something or boiling eggs so you have boiled eggs in winter. It's basically limitless what you could do with this technology. I challenge everyone on my channel to go out and think for themselves and build things for themselves. You can build things better than anything you can build or buy, I mean. Absolutely. Most of the time you can build something for than whatever top of the line item you're looking for. And that's going to conclude this demonstration, even though I'm still pushing steam here. And by the way, I put about, not even a quarter cup of water in here, and she's still pushing steam. But you can tell by my hand how big this model is. And she's still going. Even though I'm at 0, she's still pushing steam. Incredible. I hope you enjoyed my video. Please subscribe. Please click like. And thanks for watching.